The arms race between AI giants feels endless. Beat, Anthropic, and OpenAI trade blows almost daily. But now, a Chinese honey badger has quietly entered the ring.
Yeah, and we're so glad you're here with us to watch this fight. Welcome to the deep dive. Whether you're prepping for a meeting or just insanely curious, we have a genuinely fascinating one today. We are exploring Alibaba's new Qwen 3.8 Max model. We'll look at what it actually is under the hood. We'll see how it performs on paper against the heavyweights. We're going to examine what it actually builds in the real world. And finally, we will figure out if it's worth your time.
I have to admit something right up front. I still wrestle with prompt drift myself.
Yep.
You know, that feeling when the AI just loses the plot halfway through a complex task. So I'm genuinely fascinated by models that can maintain focus over long horizons.
That is exactly why Qwen 3.8 Max is making such massive waves. This is Alibaba's absolute flagship release. It's the most capable model in their entire Qwen family. They built this architecture specifically for highly complex coding. It targets deep research and heavily multimodal tasks.
Let's unpack the raw specifications first, because the numbers on this model are quite staggering. It boasts roughly 2.4 trillion parameters under the hood. That provides a massive foundation for processing complex information. But, I mean, the parameter count isn't actually the most interesting part.
No, it really isn't. The context window is what truly caught my attention. This model supports a 1 million token context window. Whoa, Pete. Imagine holding 1 million tokens in your head at once.
Let's clarify that jargon for just a second.
Yeah.
A context window is the amount of text the AI can remember in one go.
Right, which is huge.
Yeah, 1 million tokens is roughly equivalent to a dozen thick novels. You can feed it entire massive code bases without losing track. You can process dense technical documentation in a single prompt.
That scale fundamentally changes how you interact with the machine. You aren't just feeding it snippets of code anymore. You're giving it the entire repository for context. And then, well, there's the highly aggressive pricing structure. It sits at just $2 per 1 million input tokens. And it costs $6 per 1 million output tokens. Yeah, that is insanely competitive for a true flagship-level AI model.
It definitely makes running complex multi-step tasks much more affordable. But there's another crucial strategic detail we need to mention here. Alibaba plans to release open weights for a Qwen Max class model,
which is a massive paradigm shift for enterprise developers. They aren't just renting API access to a mysterious black box.
Exactly. It's like giving developers the blueprints to the factory, not just the product. You can tear the factory machines apart. You can rebuild them to process your own proprietary data. You can integrate this deeply into a secure internal ecosystem. It gives you total control over the deployment environment.
But wait, does a massive context window actually guarantee better reasoning?
No, holding data isn't the same as actually understanding it.
Right, and that's the perfect transition to our next question. Having the blueprints is great, but how fast does the car actually drive? We need to look beyond the impressive hardware specs. We need to see how this translates into actual performance against the current champions.
Let's look at the benchmark data. Qwen 3.8 Max is a massive leap over the previous 3.7 version, Beat. That much is absolutely undeniable from the testing metrics. However, it doesn't just sweep the board against the market leaders.
Yeah, models like GPT 5.6, Solar, Fable 5, and Opus 4.8 still win some tests.
Let's break down the specific coding benchmarks first. Qwen Max is incredibly strong on Terminal Bench and Frontier SWE, but where it truly dominates the field is a test called Paper Bench. I want to pause on Paper Bench for a second, because this isn't just about solving simple Python puzzles. This benchmark measures reading research and reproducing complex technical work.
Right.
It means reading a dense 40-page PDF of mathematical formulas. Then the model has to accurately translate that logic into functional code. Qwen Max actually received the highest score among all compared models here.
It also ranked absolutely first on a test called Qwen React Bench. This is a benchmark focusing entirely on building functional React interfaces. It tests component logic, state management, and modern front-end practices.
Which perfectly aligns with Alibaba's core mission for this model. They clearly want this to be a front-end web development powerhouse. But let's shift to the agent workflow categories. These tests simulate tasks requiring long-term planning and information gathering.
And Qwen Max is highly competitive on CoWorkbench and JobBench.
Exactly.
It also performs exceptionally well on the wide search benchmark. This tests an agent's ability to handle connected steps across multiple searches. It has to aggregate data from different tabs without losing its focus. Qwen Max has completely closed the performance gap with Opus 4.8 here.
It also holds its own in the general knowledge categories. It scores highly on IF Bench for strict, literal instruction following.
Hmm.
It performs very well on Health Bench and PR Bench Finance. But it doesn't create a gap on the absolute hardest reasoning tests. On GPQA Diamond and HLE, the leading models still hold their ground.
I kind of had to push back a little on this obsession with benchmarks. Scoring well in a perfectly sterile lab environment is great for headlines, but that doesn't always equal practical utility for your actual workday.
I completely agree. The lab is clean, but the real world is incredibly messy. We need to know how it handles messy, chaotic, real-world problems.
But do these agent benchmarks actually reflect daily coding struggles?
Partially, but real-world chaos often breaks these perfectly sterile tests.
Exactly, and that's why we need to strip away the training guardrails. We
Right.
need to move completely out of the lab right now. Let's look at what Qwen 3.8 Max builds from a cold prompt.
Let's examine the very first real-world test from our sources. The prompt asked the model for an interactive black hole simulation. It needed to be built entirely in a single HTML file. The prompt was incredibly detailed and highly cinematic in its scope.
Hmm.
It asked for a bright, rotating accretion disk.
It didn't just spit out a basic clunky geometry demo. It built a beautifully polished scene with strong composition and dramatic lighting.
We really need to appreciate the underlying mechanics here. Calculating spatial depth requires intense geometry and highly complex math. Asking an AI to write spatial depth and lighting is notoriously difficult. The generated code has to constantly track invisible light vectors. It has to calculate intersecting camera angles in real time without lagging.
So how does it manage the complex math for 3D lighting?
It leverages standard 3JS libraries rather than calculating raw physics.
Right, and that is a brilliant architectural approach. It uses the right tools instead of stubbornly reinventing the wheel. It acts as an abstraction layer to avoid writing raw WebGL shaders. Let's look at the second major test, which was building a procedural solar system.
This prompt required managing multiple spatial objects at entirely different speeds. The model had to carefully balance relative planet sizes and varying orbital paths, and it successfully included specific details like Saturn's rings and Jupiter's Great Red Spot.
Yeah, it even generated a fully procedural asteroid belt between Mars and Jupiter.
Mm.
What's most impressive here is how it navigated the strict constraints. It built this entire system without using any paid asset libraries.
Right.
It generated all the complex textures through code alone. It didn't rely on fetching any external image files for the planets. And the user interface remained incredibly easy to follow despite the complexity. It built side panels with planetary facts and integrated smooth camera controls.
The third test moved completely away from 3D spatial rendering. It asked the model for a highly functional macOS browser clone. We aren't just talking about a static picture of a desktop here. This tests the model's ability to handle complex front-end product logic.
It had to build a desktop with a working top menu bar. It included a dock with that classic smooth hover magnification effect.
Mm-hmm.
The generated windows were fully draggable, resizable, and could be minimized cleanly. It even included a working global toggle for light mode and dark mode.
Think about the mechanics required for draggable, overlapping windows. The DOM has to dynamically update z-indexes as you click different elements. It has to maintain active focus states without leaking browser memory. It generated functional versions of several standard desktop applications. It actually built working versions of Safari, Mail, Notes, and a calculator.
Now, it did have a few small bugs here and there. It definitely serves better as a prototype than a finished production-ready product. But as a 0-to-1 starting point, the structural code was incredibly robust. It managed multiple interaction states across different simulated applications simultaneously. That requires a profoundly deep understanding of component logic and state management.
We've seen what happens with highly structured, incredibly specific prompts. But what happens when everyday developers take this model out for a spin? Let's look at some fascinating examples of Qwen Max operating in the wild.
One user created a highly animated, deeply complex front-end interface. They successfully combined dynamic scroll triggers, 3D rendering, and custom typography. And they got a fully working result on their very first attempt.
The visual output looked remarkably polished for an AI generation. It kept the complex motion intelligently connected to the page layout. It didn't just throw erratic animations everywhere to make the page look busy. It understood the subtle pacing required for a premium user experience.
Of course, highly responsive layouts still absolutely need human review. You always have to manually check loading speeds on AI-generated DOM structures. But let's look at developer Daniel Farina's macOS clone experiment. He used the Qwen 3.8 Max preview integrated directly with the coder platform.
He managed to build a deeply complex desktop experience very quickly. The model actually completed the first working version in under 10 minutes.
Wow.
It was a genuinely fantastic prototype for such an incredibly short time frame. However, the complex window logic did eventually show some underlying strain. When multiple simulated apps were open simultaneously, the interface states began to break.
It reminds us that AI is still fundamentally a prototyping tool first. A highly convincing visual interface can easily hide fragile logic underneath the surface. State management in a web browser is incredibly unforgiving when pushed hard.
But the absolute most fascinating example was the empty repository experiment. A developer gave Qwen Max a completely empty blank code repository. They gave it one single, highly vague prompt with no defined tech stack.
No instructions either.
Right. They didn't break the massive project into smaller, manageable, step-by-step instructions. They just asked for a detailed 3D world and let the model run.
Qwen Max planned the entire project structure completely on its own. It dynamically built a detailed 3JS environment with several complex moving elements. It proved the model has some incredibly serious long-term planning capabilities. It made all the foundational architectural decisions without any human hand-holding.
But there was a highly significant catch to this specific experiment. Qwen Max took roughly 2 hours of processing time to finally finish.
That is a massive amount of computing time for one single task. We're so used to Copilot giving us a line of code in milliseconds. Waiting 2 hours is a total paradigm shift in interacting with machines. It reveals the model's distinct tendency to overthink highly open-ended requests.
Think of it like a junior developer tackling a massive, vague project. Beat. They lock themselves in a quiet room to figure out the project architecture. They need serious time to process the abstract requirements before they start writing code. It is essentially generating intermediate reasoning tokens in the background. It is talking to itself to plan the complex directory structure.
But is a 2-hour processing time practical for everyday coding?
Not for quick fixes, but fine for generating entire prototypes.
Right, and before we render our final verdict on who this is for, let's take a quick break. Mid-roll sponsor read, provided separately.
So we've seen the absolute magic and we have seen the brutal wait times. Let's synthesize this into actionable advice for you. Who is this highly complex model actually built for?
Let's start with the core strengths. The model is absolutely exceptional at modern front-end web development. It is brilliant at building interactive applications and complex 3JS spatial environments.
It handles diverse, multimodal inputs and massive context windows beautifully.
And the aggressive pricing structure makes it highly accessible for heavy, continuous enterprise usage.
But the underlying limitations are just as important to understand today. It can drastically overthink open prompts and respond very slowly at times. The overall code quality varies wildly depending on the specific task complexity.
And we have to admit, the premium rivals still produce slightly more polished results. Models like GPT 5.6 often get the logic much closer on the absolute first try.
The real takeaway here is about deeply knowing your specific workflow needs. It is an incredible, powerful tool for front-end developers and 3D creators. It is a masterclass in spatial reasoning and complex component state management.
But it is definitely not the best tool for simple, lightning-fast coding tasks. If you need a rapid instant response, you absolutely might want another tool. And complex multi-file outputs still heavily require human testing before production deployment.
You cannot just blindly push AI-generated code straight to a live server. You have to rigorously verify the underlying logic, the security, and the responsiveness.
Let's recap the big idea from this entire deep dive. Qwen 3.8 Max isn't about crushing every single synthetic benchmark in a lab. It is about making complex, interactive, and spatial web development highly accessible. It is the model that magically turns a blank screen into a functional solar system. It can spin up a highly complex macOS desktop prototype from thin air.
I highly recommend you extensively test Qwen Max on your own front-end workflows. Do not just blindly trust the internet hype or the sterile benchmark chart.
Yeah, see exactly how it handles your specific coding style and your daily project needs.
But I want to leave you with a final thought today. Beat. If open-weight models are now capable of architecting entire 3D worlds from an empty repository, how long until the barrier to creating custom software isn't coding knowledge, but simply our imagination and our patience to wait 2 hours?
Thank you so much for joining us on this deep dive. We will catch you on the next one.